network layer protocols, and IP addressing.
Subnetting. And what exactly is subnetting? The concept I've already talked about. Instead of having a very big network that supports 65,536 IP addresses, and yet we shall want to divide that network into departments, why can't we just get a way of breaking down that network into smaller networks? The concept is called subnetting. These days we have networks that have 30 users, that have 60 users, 100 users. Allocating a class A address is a bit of a wastage because the class A address will have 256 addresses, 254 usable addresses. We want only 30. We have wasted the remaining 224 addresses because they can't be used by anyone else. If they use them, then whoever is using them is going to be on the same network with us, and we don't want that. So we want a mechanism to split the big 256 address network into smaller networks, maybe 2 networks of 128 addresses each. And for each of them, we subtract 2 for the network and broadcast, giving us 126 usable addresses. Maybe 4 networks of 64 addresses each. From the big network of 256 addresses, we can get 4 networks of 64 addresses each. We subtract 2 from each of them for the network and broadcast and have 62 supported hosts on each network. Are we together? Are we together?
Yes.
Sometimes we even want networks of just 2 addresses that connect routers to another router. Really, in a network like this, we just need an address here and an address here. Do we need to use an entire /24 network with 256 addresses? No. Can we subnet that network into smaller addresses to help us connect several routers? Maybe we are an ISP and we have an entire network of routers like this. We don't want to wait West 256 here, West 256 here, West 256 here, West 256 here. No. We want to break them down into smaller networks. This is the essence of subnetting. But now, let us try to break this down more clearly. And I've talked about this. In a typical class C network, that is a /24, we have 8 host bits. With 8 host bits. With 8 host bits. With 8 host bits, what we are saying is that we can support 2 to the power 8 total addresses, giving it 256 addresses. But this, how do we get the 256? Is the number of host bits to the power 8. Sorry, the number of host bits as the power of 2 gives us the total host addresses right there. But we are saying these host addresses contain 2 that we can't use. The network address and the broadcast address. If we remove them, we have 254 usable addresses. And I'm saying this is still too large for today's companies. If any of you has gone in the field, you've found a mid-sized company, a small-sized company, they want you to network their company, and they have 15 users on their network. They have 30 users, they have 100 users, 70 users, maybe only 30, and they expect on a daily like 10 guests. So they want about 40 usable addresses. Giving them an entire /254 is kind of a wastage. And even for big companies that have 600 users, they have several departments. Each department is probably saying 60, 70, 120, 40, there may be 16 managers, maybe what, and all these total up to that. But they want each of these to be on a different network internally to them. So still a /254 addresses are too many for them too. What do? We subnet. We have seen that there are 256 addresses just because the host bits are 8. Is anyone seeing where I'm going? Can we reduce the host bits? You know, because we have a very big network because of many host bits. Can we just borrow one of the host bits, for example, changing our /24 into now a /25, because now there are 25 ones plus one borrowed one. Also changes our 8 host bits to only 7 host bits now, giving us 2 to the power 7 addresses, 128 addresses. Subtract 2 from those. Now we have a smaller network. Is anyone getting this? Anyone?
Yes.
Perfect.
Yes.
We have a smaller network. Now we have 2 networks. Every time we borrow 1 bit, remember this 1 bit can be a 0 or a 1, meaning we have got 2 new networks. Are we together?
Yes.
If we borrowed 2 bits, this one can be a 0 and this one a 1. This one can be a 0 and this one a 0. This one can be a 1 and this one is 0. This one can be a 1 and this one a 1. How many networks have we created? 4 new networks. Out of the 1, is anyone getting this?
Following.
Yes.
So subnetting is just about reducing host bits. We convert the host bits into network bits, thereby increasing our mask length and reducing the available host bits, effectively reducing the size of available IP addresses. This concept is called, forget this, all right, forget it, is called fixed length subnet masking. But there is also variable length. So let us get to this. Let's get to the core of this. Let's get to the core of this. We have a network 192.168. This is important, .1.0/24. We know that this network starts at 192.168.1.0 and it ends at what? What's the last address? Yes?
It's 255.
.255. This is the network. But we are saying it is too big. So can we split it? I want to write this network 192.168.1. The last I want to write in binary. Those are the 8 zeros. So we are saying in subnetting, for example, we can borrow these 2 and make them network bits. Are we together?
Mm-hmm.
So now, with this, what has changed? First of all, there are only 60 host bits, giving us 2 to the power 6 addresses, which is 64, giving us 2 to the power 6 minus 2 usable addresses, which is 62. At the same time, we get the number of host addresses from the host bits. And we have created a total of how many networks? 2 to the power, the number of borrowed bits. We have created 4 networks. But what networks are those? How many addresses are in each network? For that, listen carefully. Anyone remembers our chart? 128, then 64, then anyone go with me? 32, then
2, 16,
8,
4, 2,
Perfect.
1.
I have people in today's class. When we borrowed 2, moving from this side, where did we stop? On which number? On 64. So each of these networks will have 64 what? Addresses. You love the magic, right? I'm sure some of you are falling in love with this magic. You're like me. So each of them will have 64 addresses. As simple as that. So we have created 4 networks. Let me write those networks here. The first network starts at 192.168.1.0 and starts from .0 up to, and it is a /26. The original 24 plus 2. Are we together?
Yes.
Let me do that again. We have the original network 192.168.1.0/24. When we write this in the way it is, 192.168.1.1234567 and we borrow these 2 to network side, what happens is that we have the number of networks created is 2 to the power borrowed bits, which is 4 networks. And given our 128, 64, 32, 16, 8, 4, 2, 1, we borrowed this and borrowed this. So each of these networks is going to have 64 addresses. You can get this from here, or you can just do 2 to the power this. Yeah? 2 to the power that will still be 64. Now we want to see these networks, 4 networks, each of them having 64 addresses. Let us try to find them. The first one is 192.168.1.0/26. Why 26? Originally it was 24, and we have borrowed 2 more. Okay?
2 hosts, yes.
This network starts from .0 and it stops at .63.
Wow. 3.
3 because we started counting from 0.
Yes.
Are we together?
Yes.
Yes.
The second one is 192.168.1. The next address to this 64/26, and it starts from .64 up to, add 63 to this 127. We add 63, not 64, because we are counting this number also.
Yes.
The next one is 192.168.1.128/26, starting from .128 up to, add 63 to that.
191, yes.
The fourth one is 192.168.1.192/26, and it starts from .192 up to .255.
5.
These are the 4 networks. Network 1, network 2, network 3, network 4. And you can see that now we can give this network to finance department, this one to sales department, this one to procurement, this one to technical. Our company is full. The same network, we have just subnetted it. Now, I want to see something about the subnetting I've just done. The subnet mask for all the networks is the same. Do you see that?
Yes.
Yes.
This is called fixed length subnet masking. The smaller networks we have created all have the same subnet mask. Actually, subnet mask length is the same. So we call it fixed length subnet mask, but it is unrealistic. It is unrealistic. Is it possible for you to have the same number of members in finance as those ones in sales?
No.
No. Can you have the same number of students in engineering as those ones in business?
No.
No. Can you have the same number of students in computer science as those ones in electronics?
No.
No. It is unrealistic. You can't have the same number of managers to the same number of managers in a bank, the number of managers in a bank is the same as that of tellers. It's not possible. So chances are we are going to have a requirement of meeting a department that needs 11 addresses. Another one needs 60 addresses. Another one needs 51 addresses. Another one needs maybe 23 addresses. You see, this kind of thing, managers, sales, maybe accounts, maybe technical, something like that. You understand?
Yes.
So we have our 192.168.1.0/24. We need 4 networks, but they are like that. Tricky, right? Tricky, very tricky. Very, very tricky. What do we do? So what we are going to do here is to start by finding the biggest network we need, 60. Now let me ask a question in lay language. 2 to the power what? Do we get a number which is closest to 60? What needs to be the power here?
6.
6. 6 will give us 64, right?
Yes.
It is okay for it to be greater, but it can't be less. For example, if we use 5, we get 32. That one can't help.
Yes.
So we can take 6. So all we need is 6 host bits. Does that make sense?
Mm.
Does that make sense, everyone?
Yes, it does.
Hope. Oh, is Hope here?
Yes, sir.
Oh, no, John, please. John. Thomas?
Yes, John.
Thank you. Thomas, are you here? Okay. I hope this makes sense. So we need 6 host bits. So we are going to get our 192.168.1. Now, we need only 6 zeros, meaning that we are going to borrow the 2 to the network part. Are you with me?
Yes.
Meaning we are going to change from our /24 to /26. So with this, we have created 4 networks. And each network, again, we have borrowed from 128 and borrowed from 64. So each network will have 64 addresses. Those networks are 192.168.1.0/26 and 192.168.1.64/26 and 192.168.1.128, I think.
128.
128. Is it 128?
127.
128.
/26, yes. And then 192.168.1.92/. We have made 4. Let us call this A. Let us call this B. Let us call this C. Let us call this D. Now with these 4, we can clearly see that we can serve network B and we can serve network C.
Yes.
Because there is no other way of reducing this.
Yes.
Are we together?
Yes.
Now, this other network here is too big for A or D. Are we together?
Yes.
So we are going to get hold of it, 192.168.1. We know that now we have 1, and the host bits are 1, 2, 3, 4, 5, 6. We are going to subnet this again. We want 23. Okay? 2 to the power what? Do we get something
5.
close to 23 but greater than it? We need 5.
Five.
You know, 5 will give us 32. And it looks like it's far from 23. 16 is nearer to 23. But 16 is not going to help. Okay? So we take 5. So we need only 5 host bits, meaning that we are going to borrow this one, the network part. Are we together?
Yes.
Changing us from /26 to /what?
27.
27. Giving us 2 networks. Because we have borrowed 1. Remember, those 2 were already there.
Yes.
This one can be a 0 or a 1. So now we have 192.168.128/27. We have borrowed from 128, we have borrowed from 64, we have borrowed from 32. So we are going to be having 32 addresses. Then 192.168 plus 32 aggregate.
160.
160/27. Now, if we see where this address starts from 128 up to 159. This one starts from 160 up to 191. Do you see that these 2 are still in the original range of this one?
Yes.
Because this was 128 to 191. Are we together?
Yes.
So we are going to get hold of one of these. In this case, let us say this one will serve our network D. Okay? And because network A, 32 is still too big for A, we are going to subnet this again. We shall take 1 more bit, making 2 networks, 192.168.1.160/28 now. Are we together?
Yes.
And 192.168.1. This plus 16 is 86. 186/28.
176.
Are we together?
176.
1 times 16.
160 plus 16. 176.
Oh, sorry, 176. Thank you. Sorry. Oh, I was dozing. Excuse me. 176/28, giving us our solution for network A and an extra network for use in the future. So you see, we have this network reserved a /28, and this entire network reserved a /26. In future, our boss will say, oh, Mike, sorry, I didn't tell you in time. We have auditors who are coming and they are going to be working with us for these 2 weeks. Please create for them their own what? Network, so they don't interfere with our staff. And say, oh my God, I need overtime for that. I have to get back to the table and do planning and what. When he confirms that, they approve the payment, you go ahead and pull out your network from your drawer and tell them to allocate that one. You sit back and take your cup of coffee. Now you notice that the first 2 networks were /26. The next network for D was /27. The network for A was /28. This was network D. This is network C. This was network D. This was network A. What do you notice about these mask lengths? They are what?
Different.
That's what they call variable lengthy subnet masking.
Okay. I now understand this. Okay.
So this is what we have been doing, okay? And this is a practice example. You see, in this case, we have a company network that probably has 3 departments, and one department wants 10 addresses, 10 usable addresses. The other department also needs 10, the other one needs 30. Now, it's good practice to always start with the biggest one, okay? So the whole workout of this is there, and you'll have it in the notes, and you'll finally have that a /128/128, and this one will have a /27, /28/28/27. That is what you will have.